can be so straightforward to carry out division of numbers. When a number divides a number using just constants, it is not difficult to tell what the outcome will be. Or think about it. We can set out to divide a product by other numbers. When we set out to divide products by other numbers, especially in a number operation involving algebra, we can perceive that we have some other ways we can approach the process. What are these other ways, alternative ways, that always succeed when default method fails, especially in carrying out division of products? That takes us to the last lesson objective of this lesson, objective number 3, and that is law of association. In it, I explain, using numerical experiments, alternative methods of carrying out division of products, either by single numbers or by other products. Please cooperate with me. Now let us take on the third arithmetic law, and that is law of association. In this law, we are concerned with grouping of numbers during number operations, and afterwards, quotient of products. In quotient of products, we learn how to get an answer when we divide a product by a number or a term. Let us start with the first, which is grouping of numbers during number operations. Take a look at these 3 number operations. First, notice that all the 3 number operations feature the same number, the same set of numbers. 2, 3, 5, 7. 4 numbers arranged differently in 3 ways. The arrangement is partly the reason why we are talking about grouping, but the most important thing about the grouping is that brackets are used to isolate members of the number operations. In the first number operation of multiplication, bracket isolates 2 and 3. In second, bracket isolates 3 and 5. In the third number operation, the bracket isolates 5 and 7. In all, numbers are multiplying themselves. 2 times 3 times 5 times 7 is the first one. Let us check if different or the same answer will be gotten as we carry out these number operations. This bracket means that we should get an answer to the number operation in the bracket first, before taking the answer to relate with the remaining numbers in that operation. Therefore, the first one means that we have to get an answer to 2 times 3. When we get the answer, we now use that result to multiply 5 and then 7. And then eventually we get the result. Let us just do that. So the bracket means that we give attention to 2 and 3 first. If not first, anytime we are giving them attention, let it be that 2 and 3 are seen together. Okay, 2 times 3 is 6. It is as if 2 times 3 times 5 times 7 is the same thing as saying 6 times 5 times 7. What is the answer? First, 2 times 3 is 6. 6 times 5 is 30. 30 times 7. What will it be? Let's find out. Here is the answer. It is 210. Let's look at this second number operation. The bracket isolates 3 and 5. It means we first get the answer to this number operation in the bracket. That is 3 times 5. 3 times 5 is 15. So what it means is that this operation of 2 times 3 times 5 times 7 is the same thing as saying 2 times 15 times 7. Okay, 2 times 15 is 30. 30 times 7 is the same 210. Is that a coincidence? Let's find out by taking the third one. 2 times 3 times 5 times 7 in bracket. In this third operation, a bracket isolates 5 and 7 in multiplication. It simply means we get 5 times 7 first and then multiply its result by 2 and 3. Alright, 5 times 7, what is it? 35. So 2 times 3 times 5 times 7 is like saying 2 times 3 times 35. That will be 2 times 3 is 6. 6 times 35. What is the result? The same 210. 210 here, 210 here, 210 here. This bracket, or these brackets in these three number operations, are said to be associating some numbers. This bracket associates 3 and 2. This bracket associates 3 and 5. And this bracket associates 5 and 7. So we use brackets to associate numbers when we carry out multiplication of numbers, as these three operations show. It therefore means that if numbers are being multiplied and brackets are used to associate some numbers with themselves, it doesn't matter which numbers are associated. In fact, at the end, the result is the same. Let us test if the same thing happens in addition. Now we have seen that which two numbers are associated in multiplication do not or does not change the result. Anyway, let us test whether association changes results in addition. Permit me to change these number operations to addition. Instead of saying times, let me say plus, plus, plus. Let this bracket remain, but the sign here should turn to sign of addition. Let this also turn to addition, and let this also turn to addition. The same thing applicable to these remaining two operations. Please let that happen. And here comes an alternative number operation. This is addition of numbers, no longer multiplication of numbers. Here we have 2 plus 3 plus 5 plus 7. And in it, we have 2 and 3 associated with a bracket. Next, we have 2 plus 3 plus 5 plus 7, the same number operation. But here, bracket associates 3 and 5. In the third operation, we have 2 plus 3 plus 5 plus 7, the same number operation, but the bracket associates 5 and 7. Does this association affect the result? The answer is no, as you can see. If in the first place, this bracket associates 2 and 3, it is as if what we have is 5 plus 5 plus 7. The first 5 from this bracket, because 2 plus 3 is 5, so this bracket is 5, then plus 5. That is 10 plus 7, that is 17. Next, it is as if this operation is 2 plus 8 plus 7. What is 8 coming from? From this bracket. 3 plus 5 is 8. So 2 plus 8 is 10. 10 plus 7 is 17. Notice that this number operation and this are the same. The difference lies in the fact that in the first operation, the bracket associates the first two numbers. In this second operation, the bracket associates the next two after the first. And in this one, the bracket associates the last two numbers. In the last operation, the 5 and 7 are associated by a bracket or with a bracket. So that what we have is 2 plus 3 plus 12. Why 12? 5 plus 7 is 12. So 2 plus 3 is 5. 5 plus 12 is equal to 17. So the association of numbers when numbers are being added does not affect the final result. The same thing was done in the case of multiplication of numbers. But here we are seeing that whether the numbers associated are in the beginning, in the middle, or the end, whether it is multiplication or addition, the result is always constant, irrespective of the manner of association. So this is about grouping of numbers during addition of numbers and when numbers are multiplied. Before we proceed to quotient of products, it is important that we summarize our observation from here. What is it? Let's find out. And here comes the summary. The summary is in symbols. Let 2, 3, 5, 7 be A, B, C, and D. Of course, we can have less or more than these four numbers. A plus B associated added to C plus D. It's the same thing as A plus B plus C associated plus D is equal to A plus B plus C plus D associated. It means that the result you get from this and the one you get from this and the one you get from this are equal. This is number addition. Let us see what happens when numbers are multiplied in the same manner. A times B times C times D. We have it that A, B associated times C, D will give us the same thing as A times BC associated times D. The same as AB times CD associated. The result you get from this multiplication and this multiplication and this multiplication are the same. Of course, this is a conclusion of that first numerical experiment, while this is a conclusion for this latest numerical experiment. In any case, these are the summaries of the numerical experiments so far conducted. This is not the end of numerical experiments arising from our quest to explain law of association. We've just been through with grouping of numbers. It therefore means that when brackets are being used to associate numbers, when they multiply or add, the association does not affect the result. What about quotient of products? That is to say, to get the answer, we will divide products by other numbers. Permit me to use this space again to carry out a different set of numerical experiments that will help us see alternative method of carrying out division of products. Let's watch out. Now, let us take this as the first of the experiments we want to carry out to devise a means of carrying out division of products. This is a product. 4 times 6 times 7 is a product, and we will divide it by 2. So when somebody says 4 times 6 times 10 all over 2, what does he mean? What he means is that you should get the value of this dividend, which is a product. 4 times 6 times 10. First, 4 times 6 is what? 24. Then times 10 is 240. What then it means is that 4 times 6 times 10 all over 2 by default means 240 over 2. And what is the answer? Let's work it out. And here the solution comes. It says that this 4 times 6 times 10 over 2 is the same thing as 240 over 2. When 2 divides 240, the result is equal to 120. This 120 is correct, and this is called default method, a pre-selected method. Any other method that will help us get 120 as the answer and which remains consistent afterwards will be regarded as alternative method of carrying out this number operation. Don't forget that this is a quotient of products. This 120 is a quotient of products. 4 times 6 times 10 is a product, and then quotient is the answer we get after division. Therefore, like I said earlier, let us try using other methods, which can help us get 120 consistently as the answer. Please watch out. And here comes such methods. The first is this: 4 times 6 times 10 over 2. Is this. Let us try to divide one of these numbers in the product by the divisor. 2 is a single divisor. Let us try to get the same 120 by starting to divide any of these numbers by 2 and multiplying the result by the remaining numbers in dividend. I can choose to divide 4 by 2, or to divide 6 by 2, or to divide 10 by 2. But one thing is clear: when I divide one of them by these 2, I want to divide others by the same 2. This is not like the case of sum and difference, where these 2 will have to divide every member of this dividend. But because this is 4 times 6 times 10 and not 4 plus 6 plus 10, what 2 will do is to divide just one of them, not all of them. If what we have here is plus or minus, 2 will divide each of them. But now what we have is times. 2 will divide just one of them. Let me start by dividing 4 by 2. This is 4 divided by 2. The result times this 6, then times this 10. See it here. When 2 divides 4, the result is this 2, then times 6, see it here, times 10, see it here. It therefore means that this operation has become this. 2 times 6 is 12. 12 times 10 is 120. The same 120 we got by default. Right, let's go on, please. The same 4 times 6 times 10 over 2. If I choose to divide no longer 4 but 6 with 2, we now find out if the answer is still going to be 120. Now watch out, this is 4, it is still here, times. Let these 2 divide 6 and none other number in the dividend. When 2 divide 6, the result is 3. See it here. The 4 is still where it is. 10 is still where it is. I now know that you know how this operation became this one. Okay, 4 times 3 is 12. 12 times 10 again is 120. So whether 2 divides 4 or 2 divides 6, the result is the same 120. What if 2 divides 10 instead of 4 and 6? Let us see it in the third case. 4, see it, times 6, see it here, times 10 over 2, see it here. When 2 divides 10, the result is 5. So 4, that is this 4 here, times this 6, see it here, then times the 5 we get when we divide 10 by 2, see it here. 4 times 6 is 24. 24 times 5 is equal to 120. So whether the 2 divides 4 alone, or divides 6 alone, or divides 10 alone, the result is always the same. But the caution is that you must not divide all of these numbers in this dividend by the same divisor. If it is plus or minus you find here, that will be correct. But because what I'm seeing here is number multiplication to give a product, what we can see is that it is just one out of them you're going to make use of. Which means that 2 can choose any one of the numbers in the product to divide and then multiply the quotient by the remaining numbers. That is what played out here. So all these 3 are the alternative methods of finding the answer to this same number operation. This first is the default method, while these 3 are the alternative methods. In symbol, we can summarize what really happened here. Let us see the symbol that summarizes these number operations, which alternatively can offer an answer to this number operation. This is the summary. A, B, C over D. A, B, C. That is A times B times C, where our A has become 4, our B has become 6, our C has become 10, and our D has become 2. Just case in point. So A, B, C, all over D. This is typical example of quotient of product. That is getting an answer from division of a product by a divisor. A, B, C means A times B times C. It therefore means that A, B, C can be considered a product, and that product is being divided by this D. So when we divide a product by a number, this, and this are different ways we can carry out that number operation. And the result you get from this is the result you get from this, and the result you get from this, which means that this D can choose to divide any of these members of the product, and then the result of the quotient multiplies the remaining numbers in the product. That information is consistent, and if you try it out by choosing other numbers apart from 4, 6, and 10, and 2 to carry out similar number operations, you will find out just the same result. Therefore, this is summary of these 3 alternative methods of carrying out this number operation. It therefore means that the same bracket associates 2 numbers. In the first operation here, this bracket associates 4 and 2, leaving 6 and 10 alone. In second operation, the bracket associates this 6 and 2, see it here, leaving 4 and 10. In the third operation, the bracket associates 10 and 2, see it here, leaving 4 and 6. So bracket has remained an instrument of association. That means that here also, as we can see in the summary, the bracket can be chosen to associate A and D, or to associate B and D, or to associate C and D, but never A and B and C to D at the same time. Please be very careful that you don't take A, B, C to mean A plus B plus C. Just be very careful. The two look alike, but a close look will make you get more careful. This foregoing number experiment or numerical experiment features division of a product by just a single number. What if another product divides a product? For instance here, 2 is just a single number and it divides a product. What if another product divides a product? That takes us to another numerical experiment, and then the result that follows. This is that next numerical experiment in which what divides is also a product and what is being divided is also a product. 4 times 6 times 10 is a product, and then 2 times 3, which we divide it, is also a product. So in this case, the divisor is a product and dividend is a product. Compare it with the other experiment we just did a short while ago, in which the divisor was not a product. A single 2 was used as a case in point. Here, we're using 2 times 3. So here we have 4 times 6 times 10 over 2 times 3. Let us get the answer first by default and apply alternative methods to getting the same answer. Let's find out. First, 4 times 6 times 10. What will it be? 4 times 6, like before, is 24. 24 times 10 is 240. And then divide it by whatever you see in the divisor. That will be 2 times 3. That will be divided by 6. What it means is that this 4 times 6 times 10 over 2 times 3 is the same thing as writing 240 over 6 by default. Let us work it out. See the solution here, 240 over 6, and that will give us 40. This result came by default method. Any other method that we apply that will give us the same 40 as an answer and which remains consistent will be accepted as alternative method of carrying out the same number operation. Follow me as I conduct some numerical experiments, which, when well conducted, will give us the same 40 as the result. And here come those number operations that will help us see whether we can get the same answer, 40, using the methods. The same 4 times 6 times 10 over 2 times 3 is what we have as 4 times 6 times 10 over 2 times 3 times 1. Don't forget that if one divides or multiplies a number, that number remains the same. This 1 is kept here for convenience, and yet it is going to carry out a number operation to even out some differences. Here we see that we have a difference in the number of participants in dividend and the divisor. The dividend contains 3 numbers. There are 4, 6, and 10, but the divisor contains only 2 numbers, 2 and 3. For some reasons, it is important that the numbers taking part as in the product or the dividend equals the number that are in the divisor. In the dividend, we have 3 numbers. In the divisor, we have 2 numbers. To close those differences, or to even out those differences, 1 is introduced, so that in the end we have 1, 2, 3 as dividend, 1, 2, 3 as divisor. Always use 1 to even out the difference between the numbers in the dividend and the numbers in the divisor. Sometimes it is the dividend that is not up to the number of participants in the divisor. Either way, use 1 to even out that difference. In the end, the result is what is supposed to be, and yet that 1 has not caused a damage. Right, so 1 is here for that purpose. So 4 times 6 times 10 over 2 times 3 times 1. I now hope you know why the 1 is here. Let's make progress. Notice what happens next. Let us divide 4 by 2, divide 6 by 3, and divide 10 by 1. See the divisions going on here. When 2 divides 4, the answer is 2. When 3 divides 6, the answer is also 2. When 1 divides 10, the answer is 10. Which means that this number operation has become this. 2 times 2 is 4. 4 times 10 is 40. The same 40 we got when we used the default method to carry out that number operation. Is it compulsory that the first should divide the first, second, dividing the second, and third, the third? Let us find out. This time around, let these 2 not divide 4. Instead, let 2 divide this 10. Let these 3 still divide the 6, but let 1 divide 4. That means we have exchanged the numbers in the divisor. Notice what happened here and compare it with what happened here. Here, we used the first to divide the first, second to divide the second, and the third to divide the third. Here, we're using the first to divide the last, the second to divide the second, and the last to divide the first. See it play out here. When this happens, will it affect the result? Let's find out, please. When 1 divides 4, the result is 4. When 3 divides 6, the result is 2. When 2 divides this 10, the result is 5. So this number operation has become this. 4 times 2 is 8. 8 times 5, the same 40. It therefore means that we don't insist that the first divides the first, and second the second, and third the third. Instead, anyone can divide anyone. Any number in the divisor can divide anyone in the product, which is the dividend. Are we really sure? Let us repeat with different arrangement of divisors. This time around, let these 3 divide 4, and let these 2 divide 10, and let this 1 divide 6. will that arrangement change the result? Let's find out. When 3 divides 4, the answer is 1.3333, 2 times indefinite. And then when 1 divides this 6, the result is 6. When 2 divides 10, the result is 5. Therefore, this number operation has become 1.333 times 6 times 5. 6 times 5 is 30. 30 times 1.333 is approximately equal to 40. It is 40 if all the decimal places after this dot are used for this multiplication. But because we have just 4 dp, then what we get is roughly 40. Therefore, whether it is this, or this, or this, the result is the same 40. All of them are called alternative methods of carrying out the same original number operation, the division of a product by another product. What then do we say is the summary of these alternative methods? Join me as I summarize those methods. And here comes the summary. ABC over DEF is equal to A over D times B over E times C over F, also equal to A over F times B over E times C over D, also equal to A over E times B over F times C over D. The answer you get here, here, and here is the same everywhere, just as we observed here. So far, we've had about 4 different numerical experiments based on the proposed law of association. These summaries that we extracted out of the observations that we made from those experiments will amount to laws. That is, in time, they turn to laws of association. Let me write the summary of these findings or these summaries, and afterwards we call these findings the laws of association. Please watch out for a list of summaries which will become the laws of association. And this is the grand summary of all summaries. We have seen this before, this also before, we also saw this before, and most recently we saw this. All of them are called laws of association. The first 2 are the laws of grouping, and the last 2 are the laws of quotient of products. Now, let us turn attention to some examples of number operations that are carried out with laws of association when found appropriate. Let's see. Before we see the examples, let us summarize these results, which have turned out to be laws of association in words. And here comes the statements of laws of association. The first one says, sum or product of numbers remains the same irrespective of position of brackets of association. I hope this captures the sentiment you had while we learned to use brackets to associate numbers in sums and products. Next, when a product divides a product, any number in the divisor could divide only any one of the product dividend. I hope this also captures the sentiment you got when we talked about and carried out number operations of dividing a product by a product. At this point, let us see more examples of number operations which we can carry out by applying laws of association. Let us see. And here are more examples based on laws of association. We have 12xy over 4y. This is a product. This is also a product. Let this product divide this product. So based on the law that we just had earlier, that is among the list of the laws of association there is one that is going to be applied here particularly. Let us see how it is applied. First, let us realize that 12xy is the same thing as 12 times x times y. I hope that is clear. Let us also recall that 4y means 4 times y. But see one here to complete the number of times that the numbers appear. If you watch the dividend, we have 12, x and y. That is 3 participants. If you now watch the divisor, we have 4 times y. We have only 4 and y. Only 2 participants. From my earlier statements and clarifications, I said that the number of appearances of numbers in the dividend and divisors must be equal. If not equal, confusion will arise. That statement is good for all beginners. Here we have two numbers appearing in the divisor. We have 3 numbers appearing in the dividend. Which one is less? The divisor appears less number of times. While the dividend has 3 numbers in appearance, and this has 2 in appearance. Let us complete this that has 2 in appearance to become 3. How? 1 was selected. This time around, we now have 3 numbers appearing in the divisor, just like 3 appearances of numbers in a dividend. I hope what I'm saying is clear. All right, it is now time for us to apply that law of association, meaning this 4 can divide any one of these 3. This y can divide any one of these 3 numbers. This 1 can divide any one of these 3 numbers. But the caution is that it divides it only once. If 4 is dividing 12, no other one divides 12. If 4 is dividing this x, no other one divides x. If 1 is dividing y, no other one divides the y. So let us bear it in mind that we don't have double division in the application of law of association. How we choose which number divides which depends on what we expect as a result. If we choose y to divide 12, meanwhile, we're not going to get anything out of that division. We might try something else. If we choose to divide y by y, surely it is going to work. If we divide this 12 by 4, it is going to work. Anyone can work, but we're looking for the simplest thing we can get out of that division. So in carrying out division of product by product, since anyone can solve, we are glad it is possible, but to simplify it further, we'll make our choices in a way that the divisions produce whole numbers. Here, when 4 divides x, you won't produce anything, but when 4 divides x, that activity is not a wrong thing. But because if you divide x by 4, you will not get any answer. We choose a different thing that 4 will divide. Let 4 divide 12. Also, if y divides x, nothing is wrong with that, based on law of association. But because when y divides x, we don't get anything simpler, we look for something else. In fact, look at the selected divisions that took place among the dividends and the divisors. Let 4 divide 12. Let 1 divide x. Let y divide y. See it happening here. That takes us to 12 over 4 times x over 1 times y over y. I hope what is happening here is clear to you. All right. Now let's see the result of each division. When 4 divides 12, we have this 3. When 1 divides this x, we have this x. When y divides this y, we have this 1. Therefore, this number operation has produced 3 times x times 1. 3 times x times 1 is equal to 3x. It therefore means that the answer to this number operation is 3x. Was that clear enough to you? Alright, let us see example number 2. And that is 18y to the power 2 over 6y Again, let us expand the dividend. 18y to the power 2 is same thing as saying 18 times y times y. And then 6y is the same thing as 6 times y. Please, between the appearances of the dividend and the divisor, which one is not enough? Again, the divisor appeared 2 times while the dividend had 3 appearances. That means that the divisor must be made complete to 3 by use of this 1 again like the first. With that in mind, we start making selections as to which divisor divides which dividend. Will this 6 divide this y? If it does happen, it is not wrong thing, but because nothing simpler will come out of that division, we'll try something else. Will y divide 18? If it does happen, nothing is wrong with that. But nothing simpler will come out of y dividing 18. So let us make some wise selections of divisors and dividends. Let 6 divide 18. Let y divide y. Let 1 divide this y. This is what is playing out here. I will now have, when 6 divides this 18, the answer is 3. When y divides this y, the answer is 1. When 1 divides this y, the answer is y. So this number operation has become 3 times 1 times y. And 3 times 1 times y is equal to 3y. I believe also that what transpired here is clear to you. Now let us see a case where the number of appearances in the divisor is more than those in the dividend. And that is number 3. In example, we have 35x over 7xy. In dividend here, 35 is a number. X is also a number. That means that there are 2 appearances in the dividend. But here in divisor, we have 7, x and y. That is 3 appearances. This is the first case of this type where the number of appearances in the dividend is less than those in the divisor. Again, like before, we use 1 to complete it, no matter where the number of appearances is deficient. It is in divisor, it is in dividend that the number of appearances is deficient. That is why 1 is used in that dividend. That takes us to 35 times x times 1. And then this is 7 times x times y. See it here. In the earlier examples 1 and 2, it was in the divisor that the number of appearances was deficient. But this time around, it is with the divisor. Let's proceed. Again, let us make wise selections as to which number in the divisor divides which number in the dividend. Anyone that can divide anyone, but we target a division that will produce a result. Let us not produce a result that has alternative answer. Instead, let the result we produce be the best we can get out of a number operation. 35, let 7 divide it. This x, let this x divide it. This 1, let this y divide it. See the procedure here. 35 over 7 times x over x times 1 over y. That is 7 divides 35, x divides x, and y divides this 1. See it here. So when 7 divides 35 now, the result is this 5. When x divides x, the answer is 1. And when y divides this 1, the answer remains 1 over y. Please, nothing comes out of it when y divides this 1. But when 1 divides y, the result is y. That must have become clear at the time you learned the fundamentals of algebra, which I taught earlier. All right, at this point, please, 5 times 1 times 1 over y, what will it be? Is it 5y? No. How? Please put over 1 under this 5, over 1 under this 1, and 1 over y. In fact, let me put them to make it clearer as to how we got this 5 over y. And here they come, the 1 here and the 1 here. The 1 is necessary for us to see this as fractions being multiplied. So we're going to use the principle of multiplying fractions to get the answer to this number operation. that will be 1, 2, 3 multiplied times, okay, over 1, 2, 3 multiplied. So 5 times 1 is 5. 1 times 1 times y is y. So at the end, the result is equal to 5 over y, not 5y. Be very careful with the way you produce answers from such number operations. With these 3 examples, I believe that we can tackle anything that has to do with division of products by products. Please watch out for an exercise. And here comes the checkpoint. It says, evaluate the following operations using an appropriate law of association. The first is 30 times 10 over 5. Number 2 is 24xyz over 4. Number 3 is 20c squared over 5c. Number 4 is 28g over 7gx. Number 5 is bxg over 2x to the power 2y. The number 6 is 21m to the power 2 over 7m to the power 2 cg.